Yeah. I'm glad you noticed. All right, so here we go. Example 5. I try to find interesting gifts, whatever. Yeah. Put it on my jag. Example 5b. So we're going through how do you solve trinomials with an a, right? The x1 in front of your squared, other than 1. First, multiply the coefficient of the x constant term to the constant. Right, and then you rewrite it with the new c, and then you factor it, and then you put in the coefficient again and see if you can reduce. Okay, those are the steps. When I write 1, 2, 3, 4, 5, it's right above. Same page, it says 1, 2, 3, 4, 5. That's what I'm referring to. So, example B. First step, what we're going to do, we see a coefficient other than 1 in front of my x squared. I have 5.
You do 5 times 6?
Exactly, I'm going to do 5 times 6.
That's 30.
It is. All right, so I do 5 times 6. Second step, rewrite everything without the coefficient in front of your x squared, but with your new constant, right? So Felix said 5 times 6 is 30. Now the third step is we are going to factor. What two numbers will multiply to 30 but add to 13? 10 and 3. Okay, cool. So we see 10 and 3. You add them, it's 13. Maybe you thought 15 and 2, trick play, it's 17, doesn't work. Okay, so let's write it out. I have x plus 15 and x plus 2. And then the fourth step is now, I'm going to rewrite, yeah, my bad, it's 10 and 3. Because well, this would be negative and then multiply to a negative 30. This is a positive 30. Yeah, because I was showing you other factors and I wrote the ones that aren't right. It's just so loud. Okay. All right, step 4. What we're going to do is now that we factored, we're going to put back in the coefficient that we took out. So I'm going to rewrite both of these factors with my 5 in there. Okay, and then the fifth step is see, can we reduce either one of these? Yeah. Check out the left side, 5x plus 10. They have a common factor. They both are divisible by 5. Okay, so I'm going to divide both these by 5. So I get x plus 2 and 5x plus 3. So when you're doing this, you have to look to see if both of your factors can be reduced. On the right side, 5 and 3 have no common factors besides 1, so we can't reduce it. And keep in mind, this, we're only supposed to be factoring, right? It only just says, oh my God, load. It just says factor each trinomial. Did we factor it?
Yep.
Yes, that means we're done. If it says solve, that would mean now we set to 0, then we set each factor equal to 0. So like you'd have to keep going.
What is it 5x plus 2 go?
What? X plus 2?
5x plus 3. No, I get that.
The 5x plus 3?
No.
Okay, so did you get how we did the first 3 steps?
Mm-hmm.
Okay, the fourth step says put the coefficient that you took out in front of x squared, which was 5, back in front of both of your x's and your binomials. Mm-hmm. And then once I put those 5 back in, put the 5 in front of the x again, then I try to simplify it. Okay, perfect. Now let's try C. And keep in mind, if we can't actually factor, if this isn't going to work, it's going to be prime. Prime means you can't write it as a multiplication of product, multiplication of 2 polynomials. So if I can't actually write it as 2 binomials, it's prime. I don't know, I didn't say that. It is prime. Yeah. I was just reviewing the definition before we use it. So if you're done with C, go ahead, take this opportunity to put your phones in the red hanger, because it says it on the board, it says it in the syllabus, and I say it every day. So just put it away now, and then I don't have to deal with it. Okay. What? Sure. Done. On your way back, will you do me a favor? Ask one of the math teachers who are sitting there if they'll grab the copy of notes from the printer.
Sure.
That's what I was going to go do, was grab the notes for Jordan. I forgot. That's what I was going to go do, and I forgot. Grab the notes for you.
Oh,
I printed a new note packet for you.
Oh,
Yeah. Yeah, on your way back, just stop there and do it. Thanks. Perfect. 2x, all right, so 2t squared minus 11t plus 7. We have a coefficient in front of our squared other than 1. So I'm going to, first step, multiply it. Second step, rewrite without that coefficient. T squared minus 11t plus 14. Third step, factor it out. So we're looking for what will multiply to 14 and add to 11. So the factors of a 14 are 1 and 14, 2 and 7. So if I add these, I'll get 15 and I'll get 9. Wait, this is not adding to 11. So did we mess up somewhere? Like, wait, so the middle is supposed to be multiplying, so the middle is supposed to be adding to negative 11 and multiplying to 14. So the only way you can add to get a negative and multiply to a positive is if they're all negative. So let me make them all negative. Does this change our answer? No, this still is not negative 11. It's still not adding to a negative 11. So unfortunately, we can't factor this. Now, if I can't factor and write it as a product of two polynomials, literally product two binomials, then it's going to be prime. So I can no longer do anything else. I say it's prime. And when you get a quadratic that is prime, that's when you use the quadratic formula, because your roots will be like decimals or they'll be imaginary numbers. But notice we tried factoring before we went to quadratic equation. All right, so there's a hierarchy. There is literally a system. You have to go through the steps in order. So right now, right, we're doing examples from what we just learned. But when I say solve, anyway, so later today, I'll give you a couple questions and you're going to have to figure out, well, wait, what do I solve? The order is, first, check if there's a greatest common factor. Pull it out. Factor it out if there is. Then you see if I have a perfect square trinomial or a difference of squares, right? The special cases. If you don't have that, then you factor. And only if you tried all the above and you can't do anything and you tried factoring and it's prime, that's when you do quadratic formula. Okay, so I'm going to say this every day so it's in your brain. So in the test, you will follow that order.
So if we see 3, first try this.
Well, you try factoring out a greatest common factor. Always first. Then you see, is it one of our two special cases? So we're going to go through our special cases today. Then if it's none of those 3 cases, then you say, okay, try factoring, then quadratic equation. Okay, so we see this is prime. Nothing fits our criteria. We're done. Because it said to factor. If it said to solve, then we would actually have to put in the quadratic formula. It doesn't. It just says factor. We can't factor, so we're done. So D. Let's try D. So I'm going to have you give it a shot. Give about, 15 seconds. Try setting it up. If you haven't already, try out D. See if you can get the ball rolling yourself. The idea is you try it, so that way you know where you're going wrong, what your confusion is.
Basically, I just do 2 times 24.
Yes.
That's 48.
Okay. Good. That's the first step.
I got you.
No. That's the first step.
It's like 2x plus 6, yeah?
Can I bring my whole bag here?
Your full
And so
bag.
Yeah, I thought I said here, did I not? Okay. Means I need to go grab it.
So the answer is x plus 3 or the bathroom?
What?
Yeah.
Bathroom house, sure. Thanks.
Is it x plus 3 and x plus 4?
It's not stapled? No, it's stapled over here.
I got it correct. Yeah, can I give you my card and you get me some popcorn in the bathroom? Oh, no. I tried though. No?
You literally had a 15-minute nutrition. Okay.
I
So
actually
now we
did
go
that.
through and we're going to rewrite. Put the coefficient 2 in front of each of these. And then is there a common factor between 2 and 6? Yeah. Common factor in 2 and 8? Yeah, ooh, they both can be reduced. Oh my goodness. Look at us go. Okay. P plus 3 and P plus 4. So the reason is because notice I could have rewritten my whole original equation as, pulling out a 2, as P squared plus 7P plus 12. It's because I had this 2 and there's a factor of 2 everywhere. So we could have factored that out at first. And then wait, this doesn't have a coefficient other than 1, so I could have just factored like normal and we would have got P plus 3 and P plus 4. So that's why it cancels out of both, is because there was a common factor of both. Cool. Well, I mean, it's better you like go through it now and like it's rough. Hopefully get out the rough patches now so that way at home it's not rough for you. Try out example 6A. I want you to try 6A. It's the same process.
So many.
Correct. That's why it's like 2 full days of class.
With the zeros, I'm actually.
Yes. So we'll factor, but then we won't be done.
Zeros right now?
Hold on. So we factor like we've been doing, and then once we hit the factored, then you set each factor equal to 0. So it's like what we were doing before, putting it all together.
Wait, can you scroll to the part where it has the
So basically
steps?
what?
Could you write the steps?
There's the steps.
God.
No.
Those,
That's not fair.
So then wait, are you saying you factor to the equation and then you...
And then you set each factor equal to 0.
So like,
What the fuck?
wait, what?
I have mine. Oh, dude, she left the room. We can all. Oh, there's a lot of teachers in there. Huh? Am I? So. Yeah. Oh, dude, sauce me again. Oh my god. Carly, what did you started? Kimberly?
Okay.
I guess that's so much. Oh, just that.
Cool.
That's for last.
Okay, cool. Let's go through it. So, solve each equation. Oh my gosh, there's a coefficient in front of x squared other than 1. So let's use what we were just learning. So I'm going to take the 3, this is the first step, go and multiply it by the 6. Now I rewrite my equation.
You okay?
Factor, are you okay?
Yes! Yes! Thank you so
All right,
much, my God.
so we're looking for what multiplies to C and adds to B. Looking for what multiplies to 18, adds to 11. What numbers multiply 18, add to 11?
I'm in my day. I am too.
You're saying you secretly love X plus...
No, it's not a secret. I do love you guys. It's just, there's a thing called, like, I can love someone and still be frustrated to be like, work, dang it. Do you think I enjoy giving out bad grades? No.
No.
I don't. I don't enjoy it at all. Dang it. I'm trying to make you have A's. You need to try too. Okay, that's all I want.
I try my hardest.
Okay. What 2 numbers? Did we do this?
Do 11.
9 and 2. Okay, thank you.
Congrats.
Okay. Okay, so focus. Adi, do you need to be moved? Adi, Tal, do you guys need to be separated? Do I need to put in some laws that my kindergarten teacher used?
Yes. What do I do? Can you propose them and then decide?
So, there's a thing called the talking stick. I'm going to have the talking stick, and no one else will get it. When you have a question, I'll walk over to you and give you the talking stick. That's what we need to do, apparently. Guys, imagine having... Okay, you know what? I'm done trying to, like, nicely rope you in. I'm just going to mark you down. Some people were already tardy today. Class starts at 55. You're already tardy. You're losing half your participation points. You're talking. We'll just mark you down. Goodbye, and I'll send you out. I want you to focus and go through these questions so that way you don't come to me and be like, I don't know how to do homework. No, you do. I'm trying to go through it right now. So, Third step, factor. Fourth step, put back in the coefficient we just learned, that we just took out. So I'm going to write this as 3x plus 9, 3x plus 2 equals 0. Okay, that was the fourth step. We put it back in, and then we see if there's any common factor that we can cancel out of either binomial. I see 3 for the first one, so I can rewrite this as x plus 3. And then wait, I can't change the second one, so I have to leave it as 3x plus 2. So that is what we did in the previous example. Now we have a little more to do, but it's not much. It's just a little more. We factored, but now that's factor we have to solve. All right, so we set each of the factors equal to 0. So I set each of the factors equal to 0. So I get x equals negative 3. And x equals negative 2/3. These are our two solutions. And remember, what are other words for solutions? Solutions are the roots. They are the, what other? Okay, hold on. So there are solutions, are our roots, our zeros, and our x-intercepts. X-intercepts. So this is telling me where our parabola crosses the x-intercept. So just knowing these facts, I'm going to draw 2 dots. So I have a negative 3, and then when x equals negative 2/3, so that's about right here. And looking at the parabola, which way is it facing? Do we know? Look at the coefficient in front of x squared. It's a 3. It's positive. If you're happy, positive, you're smiling, so it's going to be a U shape. Look at you go. You already know what the parabola is going to look like, and you know where it crosses. So like this sort of like base level intuition helps you quickly check if you're doing things correctly. Like, huh? Halfway between those two. Yeah, it's gonna be halfway between. I don't. The only things I know for sure are where it crosses and which way it's going. But this is a rough idea of what it's gonna look like. Is this graph paper? Do I have like tick mark axes? No. But this is, if I would have to graph this, like, I know what it roughly should look like, right? I should cross at those two and like point up. Having this, it's like little bits of tools. Like how long did that take us to realize? Oh, pointing up, positive points up, cool. 2 seconds if you like know this. And understanding that the solutions that we found are the x-intercepts. They're the solutions, there's the roots, there's the solutions, the zeros, they all mean the same thing. So on your calculator, it says zeros. And same thing. Okay, let's try out B. Do I want to try out B? Yeah, let's do it. First step. Take your coefficient and multiply by your C. Second step, rewrite. Taking out the leading coefficient and rewriting our new C. So that was in quotation marks. Our new C is the 10 times 7. And notice I have everything set to 0 here. So after I factor it, I have to set each factor equal to 0. So there's like 2 parts. First factor, then set each factor to 0. So I'm looking for numbers that will add to negative 19, multiply to 70. So notice we're multiplying to a positive, but adding to a negative, that means both numbers must be negative. Yeah. Yeah, what is it? Go ahead. Negative 14 plus negative 5. Okay, that's negative 19. Negative 14 times 5 times negative 5. Well, 14 times 10 is 140. So if I multiply by half of 10, it would be half of 140, which is 70. Yeah, look at that little cheeky. That's why Common Core math makes so much sense to me, because it's the way I think. It's literally the way I think about math. Okay, negative times negative is positive. Rad. Let's go ahead and let's rewrite this in binomial form. P minus 14 and P minus 5 equals 0. Okay, now think to yourself what the next step would be. Think. Don't say it out loud. Don't say it out loud. In your brain. Not out loud. In your brain. Think about it. Okay, so hopefully by now we thought of something. Turn to your partner next to you and discuss. What do you think the next step should be? What should we do? Felix, turn.
I don't have it yet. So bring it down.
Do you know?
Bring down the 10.
Bring down 10. And then, okay, after we put the 10 in, now what?
We have to find the GCF. Right?
Okay.
No.
Greatest?
No. Yes.
Should the GCF, the greatest common factor?
Yes.
So I can divide the right side by 5, right? This one. And it would be 2p minus 1. What about this other side?
2p minus 4.
They both are divisible by 2. Ah, tricky trick, because both factors can be reduced. You gotta reduce both. Check to reduce both. Yeah. Okay, now, Felix, what do we do? Now we factor, now we have to?
Equals 0.
Yes, set equal to 0. Wonderful. We have our factors, set each factor equal to 0. Okay. So I'm showing steps I go through. It's just a 2-step equation. Add 7 to the other side. Then you're going to divide by your 5 to get p by itself. For the other side, once again, it's a 2-step equation. Got to add 1 to both sides. And then you go through and you would divide by 2. So we have fractions as answers, but like this is okay, right? You can do it. We only get fractions at the very, very end, so. This is acceptable. This is an okay answer. Cool. P is 7/5 and 1/2, meaning those are the two numbers. If I plug in 1/2 for all the p's, I should get an answer of 0. If I plug in 7/5 for all the p's, I should get 0. So all the p's meaning the actual equation up above. Okay, do we feel a little more confident about this? So we started it yesterday and I said we would do a couple more examples today. Perfect. Okay, I'm going to come back to example 7 because I realized when I was making your notes I should have put this after the difference of squares. So we're going to go to midway to page 29. And then we can come back to those examples later, but I need to go into difference of squares more thoroughly.
What page, man?
We're on the top of page 29, actually midway through page 29. So, difference of squares. The name tells you what to see. Sit up. What are you doing? Felix, sit up. Thanks.
Oh.
Okay. All right. Difference of squares. So difference means subtraction. If you have a difference of two numbers, it's a subtraction. And of squares, meaning I'm taking two things that are squares. So a square is something where a square is like 25. 25 is a square. It's a perfect square. Because what times itself is 25? 5. 81 is a perfect square. What time? 9. Okay. How about 144? 12, right? 12 times 12 is 144. What about x squared? X, right? Because x times x is x squared. So when I have a difference of squares, it's two things that are squares being subtracted. So example is x squared minus 9. It's a difference, a subtraction of two squares. X squared is literally x times x. 9 is 3 times 3. So a difference is going to be x squared minus 9. And the way you factor it is you have your x and your 3, your x and your 3, and one of them is a plus, the other is a minus. That's it. That's it. But wait, normally when we FOIL, we get 3 terms, right? We get a x term, we get an x squared, an x, and a number. What happens when you FOIL a difference of squares binomial? So when I have, so let's do like x minus 5 and x plus 5. This is going to be a difference of squares because it's the same thing. It's an x and it's a 5. The only difference between those two binomials are a plus and a minus. So if I FOIL this out, I get x squared first outer plus 5x inner minus 5x last negative 25. What happens to the middle two terms when you have a difference of squares? They cancel. They go away. So that's first, outer, inner, last. First, outer, inner, last.
What?
Yeah. First, outer, inner, last. And if you're like, oh man, I forgot about this. Guess what? New Alex topic open today. You just do Alex. While we're on the topic of Alex. So, this week, today is the 15th, right? And then next week, we have a whole week of school, 5 days, so the 22nd. All right, and there's a basketball tournament. You guys should totally go. That's rad, a full week. And then, that's the 22nd. And then opening, so that's a week. And then on the 22nd, guess what? We only have 3 days of class, and then it's Thanksgiving.
Class or school?
It's school, 3 days of school.
Yes.
So I'm letting you guys know. Yeah, my dad's coming out to see me.
Oh, no way. That's like,
Yeah, he's driving from Nebraska.
Whoa.
Yeah.
That's a
So I'm letting you know, over Thanksgiving, there's a Friday, but we don't have class. Weird. So on the 22nd, it's going to encompass two weeks. So that's not this Friday, not today, but next Friday, Alex will open where 10 topics will be due, but it's over 2 weeks.
Oh no.
So it won't be due the 29th, it will be due the 6th of December. So literally, one of the days before Thanksgiving, you could knock out all of Alex for the 10.
Knowledge check count as 5 topics?
Yes.
Because I did knowledge check last night, so maybe do 5 topics.
so,
I did it. But it's
Well, it doesn't automatically count as 5
so we have
topics.
to do.
I say it counts. But if you did 5 topics, like, darn, you're getting better at math, shucks, like,
so I
shoot.
just account for next week?
No, it doesn't.
Knowledge check counts, right?
Yeah, and I saw you did one, and
I can't
I,
believe you would say that, bro. What?
huh?
So disappointed.
I also see how long it takes someone to do knowledge check and how many topics they master. Okay, so, shh, what? You get a 0.
Really? How many topics is a good
Yes.
number to master already?
Yeah,
Scared to do that.
because I literally told people, you must have an honest effort. There's no honest effort if I see 0 topics learned, or if it's like a short amount of time. So I see how
I thought
many.
you said you could.
That's not all what I
Last
said.
year, Miss Coach class, I purposely failed all of them.
Cool. I'm glad you're wasting $60. All right, so I'm letting you know. Shush. I'm letting you know right now. There's a 2-week span where 10 Alex are due. I don't you can ask me this question, but I'm being as clear as possible so you aren't surprised when you're like, why does it say 10 topics? Oh, because you have 2 weeks to do it. Okay, cool. Just thought I would warn you that that's coming to you. All right, so now we're covering difference of squares. So let's factor each polynomial. Look at the directions. Factor. All we want to do is factor. If it's not possible to factor, we say prime. So let's go ahead and let's factor. So, Felix, sit down. Right, we're not distracting others. So a squared minus 25. This is a difference subtraction of 2 squares. A squared is literally a times a. 25 is just 5 times 5. So to factor, we would say a plus 5, a minus 5.
Wait, is that like all we have to do?
The directions say factor. Is this factored? Yes. Okay. Let's try the next one. The next one is a 3 words. Difference of squares. Once again, because it's 81, which is a perfect square, and t squared, which is a perfect square. Difference of squares. It's literally going to be the square root of your first plus and minus the square root of your second. The square root of 81 is 9. The square root of t squared is just t. Because you're asking yourself, what times itself is t squared? Oh, t. So it's going to be 9 minus t and 9 plus t. So although the order doesn't matter in the sense that I could have written this as 9 plus t times 9 minus t, the order inside does matter. So notice the thing that you're subtracting, the minus t squared, the t has to be on the right side. So whichever one is on the right in the original must be on the right in your factor. Right? So you see how the t is on the right of 81, so it's got to be on the right of your 9? Okay. If you don't, it's a much different problem, so you have to make sure to stick that. Okay, let's try C.
So, cool. That's 2.
And if I did not give you enough time to write down, just let me know. Because I'm trying to see if people are done writing or not. So this one's a little harder, but it still is a difference, right? A subtraction of 2 things that are squares. So what times itself is 64? 8. And then what times itself is g squared? G. Okay, so I'm setting up by my binomial. And then what times itself is h squared? H. So 8g plus h, 8g minus h. Perfect. Let's do another example. This one's a little harder, a little trickier. So we have an x to the 4th term. So what times itself is going to be x to the 4th power? X squared, exactly. So I can write it as x squared minus 4 and x squared plus 4.
Is that an supposed to be close?
Good question. Ask that again, but louder.
I don't think it is.
No, ask exactly what you said. Say it again.
That is simple as
Is that in simplest form? No. Why?
Because there's x squared.
Because we have an x squared minus. Yeah, that's a good one too. But technically, this one you could write. No, never mind. Nah, it was supposed to be 2. I was doing the problem that's on the next page. Sorry. When I go like this, say what you said before, okay?
Alright, I got you.
Okay. Sorry, that was a little ahead of myself.
It's like an orchestra. You point to.
Wait, that's the answer. Right?
Yeah, because 2 is not a perfect square. Okay. What? Do you mean to go back? What are you looking at?
Can I? The trash can. Can I?
Are you gonna throw up?
Just send it, bro.
What are you doing?
Can I?
If he makes it, we all get an A.
That's not. I'm not agreed with that. Just throw it. Just throw it. Okay, entertainment. Oh, okay. You get F. Ah, everyone gets Fs. Okay. So, let's factor b to the 4th minus 1. B to the 4th minus 1. Y times itself is b to the 4th.
B squared.
B squared minus 1, b squared plus 1.
Wait, how did you do the one?
What?
How did you do the one?
We already did it with d?
Yeah.
Yeah. Up here?
Oh. No.
Okay. So, I have b squared minus 1 and b squared plus 1. Ready, guys?
Is that a simple form?
Is that in the simplest form? Wait. Do I have another difference of squares?
Which one are we looking at?
I'm sorry, we're looking at E. He wanted to look at D again.
You do.
We have another difference of squares.
It could be simplified.
Oh, so is it b minus 1, b plus 1?
Oh my gosh, I can simplify this one into b minus 1, b plus 1, and then I still have to write this one down here as b squared plus 1. This is the final answer.
Wait, why is it 3?
No, but can't you simplify the other one as well?
No, because it's not a difference of squares. It's an addition. Difference has to be subtraction.
Difference.
Because it's subtraction, because it's a difference. Felix, turn around. All right. So, we had a great question. Can't we simplify this further? No. Because it's not difference, it's an addition. A difference is subtraction. It has to be a subtraction of 2 squares. Because if I set this, yeah, that's why. So the next lesson's over imaginary numbers. So if I wanted to write b squared plus 1 out, it would literally be b plus I and b minus I. But you're like, what the heck is this? Let's not get ahead of ourselves. It's the next lesson, so we won't do that now. But all we're caring about is difference of squares.
Wait, hold on.
There's a lot.
We use it all the time in calculus, but you learn it now as well. Okay, so let's try F. Try F. Over here, can I factor it?
Can I do it, please?
Sure. What is it? How do I factor it?
Oh, got him. Cooper, you got it.
So let's try it out. Let's try it out. Hold on. Ready? Let's try it out together. So I'm gonna say 3 plus x, 3 minus x, and so I'm testing this. Shh. Hold on. Let's focus. Right? Ears open, mouth closed. So if I'm going to FOIL this out, if this is the answer, I should get back what I started. So I'm gonna FOIL it and see if I get the same thing. Minus 3x plus 3x minus x squared. The middle 2 go away. Oh no, this is not the same. Because this is not a difference, it's an addition. Difference is subtraction. Difference, subtraction. Difference of 2 squares has a subtraction sign. So can I factor this at all?
No, it's a prime.
It's prime. Exactly, it's prime. I can't factor it at all.
Why is it a negative?
What?
Yeah,
It's
why
not.
can't you just do 3?
This is not it. I was testing to see if this is the same, and this is not the same. That's how we know it's prime.
In parentheses, 3 plus.
Just a second. I'm going to wait till everyone's quiet. I want you to feel uncomfortable with this silence. I want you to feel uncomfortable. I'll wait 2 more seconds. Face forward. Felix, what are you doing? Please, come on, focus. All right, Natalie, what's your question?
Why can't you just do 3 plus x and then 3 plus x? Like, why do you have that?
Well, good question. Let's see what happens. If I FOIL out 3 plus x and 3 plus x, I get 9 plus 3x plus 3x plus x squared. This is also not the same thing. So it is prime. So what she just said, this 3 plus x, this, what we just found, was a perfect square trinomial. Try 3 nomial numbers, 3 numbers. And it's a perfect square because I could literally rewrite this as 3 plus x squared because it's the same factor twice. That's the next thing we're going to discuss, probably like 5 minutes. Yeah. What? Yeah, we have more than 5 minutes.
Wait, actually?
We have 12.
Maybe 12?
No, you have 12 more minutes of class before this ends.
11.
So,
I don't think so, pal.
let's solve by factoring. So now I'll wait till you're quiet before we go on. Alright, so marking people off in 3, 2, 1. Perfect. Cool. So, here we go. We're going to solve by factoring. First step, factoring has to be set equal to 0. No, I'm not. No thanks. Alright, solve by factoring. It has to be set equal to 0. So I need to get everything on one side. So now I have everything set to one side. Is there a greatest common factor?
Yes. No.
No.
4.
No. 4 does not go into 25.
Oh,
Is it a special case? Is it a difference of squares or perfect square trinomial? Yes, it's a difference of squares. So we're going through the hierarchy, going through the order. It's a difference of squares. A difference, subtraction of two things that are square. 4y squared, what times itself is 4? 2. What times itself is y squared? 2y.
There's like so many different ways.
Correct.
I'm so excited to use all of them.
That's not good.
That's fun.
Okay.
This is like the same thing, but
No,
it's
I'm
not.
just getting lost like with the names.
He's lost in the sauce, you know.
Like I know this type. This what we're doing right now. Like I remember that from my previous year.
Yeah.
The quadratic.
The quadratic formula? Yeah, we haven't done it yet. It's a later section. But I'm trying to like ingrain the order you go through. Trying to ingrain the order you go through. So that way when you're on your test, you're like, I don't know what to do, freaking out. Like, okay, first check for this, then try this. Right? I'm trying to have you have this method. Okay. No?
I'm just gonna memorize it and then write it out.
Perfect. All right, what is the, so this is the difference of squares, right? There's a subtraction. What times itself is 25? 5. So I have 2y plus 5 and 2y minus 5. I fully factored my, I could have 2y minus 5, then 2y plus 5. Because when you multiply, it doesn't matter the order. But inside the binomial, it does matter the order. What's wrong?
That was a stupid question when you answered it. It was
Okay.
not related.
It wasn't?
It was.
Okay.
It actually was.
It's a really bad question.
So notice it wants us to solve. It doesn't. Shh. It's not just saying factor. It's saying solve by factoring. So we factored. Now we have to solve. When you solve, you set each of the factors equal to 0. So I set 2y plus 5 equal to 0. Now it's a two-step equation. Two steps. First, subtract 5, then divide by 2. Now I do the other side. Set it equal to 0. Then get y by itself. So we have to use the proper order of operations. Add 5 on both sides to get 2y by itself. Then you can divide both sides by 2. So I see there's 2 solutions, 2 numbers that will work. Well, one's positive, one's negative.
I thought that.
Sorry, I tried to make it clear. All right, let's try B. Ooh, fraction. Ooh, but we know. What times itself is 36? 6. So what times itself is 1 over 36? 1 over 6. 1 over 6.
You just copied what you said.
No, I'm just delete.
I swear this is around the type of most likely. Fraction is like,
I'm too
Yeah. Well, that's one of my goals is to have you guys not be. I don't want you to see a fraction shut down and not do it. You know? Felix, go talk to Beth. You're turned around and you're not even paying attention. Go. Okay, let's keep going. So I fully factored. It's a difference of squares. It's a difference of squares. So now that I have it factored, what do I do? Please don't have the table like this. Okay. Yeah, make sure you guys aren't leaning back on chairs and stuff, because apparently there's been at least one chair a week that's breaking because people are leaning back on it. So I received an email. So I set each of these factors equal to 0. And then I solve for x. X minus 1/6 equals 0. How do I get x by itself? Add 1/6. Notice, x is being subtracted by 1/6. So to move to the other side, you have to add. This is not 1/6 times x. It is being added and subtracted to it. Okay. I don't know how to be more clear than what I'm being right now. Okay. Here's one solution. And now I set the other one equal to 0 as well. So there's 2 solutions. Awesome. Yep. If you're done with this one, go ahead and try out C. And remember, the order we go through things, we always check for greatest common factor first. Can we factor anything else out? So try out C. Give it a shot. C. All right, part C. Where do you freeze? Do you know the whole problem, or what is crippling you from finishing the problem? Yeah? So we're have to solve. So first, get everything on the same side. I'm moving everything on the same side because we're trying to solve. Have it set equal to 0. Zero equals 49a cubed minus 121a. Okay, have it set equal to 0. So we're going to try to factor to solve. First step, greatest common factor. Is there anything that's in both of these terms?
No. 7. Oh, A.
So let's try 7. 7 goes into 49. Does 7 go into 121?
No.
No.
A.
A. Is A in both terms? Yes. Let's factor it out. Now I have 49a squared minus 121. Do we know what 49 a squared minus 121 is? It is a blank of blank. Difference of squares. There's a subtraction sign. Difference. Both of these are squares. 49 is 7 squared. 11 squared is 121. Difference of squares. So I can write this as 7a minus 11, 7a plus 11. I'm going to pause here. Think about what questions you would have. All right, so we went through the hierarchy. First we said, is there a common factor? Then we said, is it a special case? If it wasn't a special case, then we would go on and try factoring before we would try quadratic formula. The difference is squares. It looked much harder, but secretly it's very doable.
How did you know that you had to do that?
Well, this is the hierarchy. You always check greatest common factor first. Greatest common factor first.
Was A different squares?
What? What do you mean? Right here?
Yeah.
Yes.
It was.
Yes. That's why we had the exact same thing, 2y and 5. One's a plus, one's a minus. I'll give you a hint. All of the examples that we're doing right now are difference of squares because we just learned difference of squares. Tricky. Trick play. It's like I did this on purpose. Examples of difference of squares. All right, so now I have to solve. It didn't just say factor, it said solve. How do I solve? Set each factor equal to 0. Okay. I don't know if you can tell. I am trying to pound this into your brain. You factor, then you set each factor equal to 0. Okay. Huh?
It's hella good when you do that.
Would you set one?
Specifically like solve it.
Would you set one as A?
Trying. Set,
actually.
set each factor 0. Set each factor 0.
Wait. Oh, never mind.
Set each factor equal to 0.
7 over 11.
So there are 3 solutions. So this is weird. This is weird. This is not a quadratic, but like we had to use 2 different factoring methods. We had to pull out a common factor and then do difference of squares. So wait, when we're solving our solutions, it's the same thing as roots, the zeros, and the x-intercepts. So that tells me that our original equation, the 49a cubed minus 121a, crosses the x-axis at 3 different points. So while this is getting a little ahead of ourselves, if we look at it, like, you know much more stuff about these equations than you know. Like, you know, okay, whatever this equation is, I know it's crossing at 0. Let's see, 11 over 7 is 1 and something, okay? Negative 11 sevenths is 1 and some remainder. And if you know, do you know what y equals x looks like?
X is somewhere on the wall.
What's y equals x look like? Ready? X squared? X cubed? Ah, it looks something like this.
Negative is like this.
It's a little switcheroo.
No.
So you already know what this looks like. So it's in like 1 minute. So it's pretty powerful. The fact that we keep finding solutions, you keep finding the x-intercepts. So it's a good place to stop. I'll see you guys next week.